By nature, man has always been an inventive creature. Probably always will be. His own curiosity and needs prompting and stimulating the creation of new ideas. This inventiveness is very evident if you take a look at the explosive growth that's been occurring and still is occurring in the areas of communication and information interchange. But the innovations and developments which have brought new levels of sophistication plus extended capabilities to these areas have also brought problems. It's all very well having equipment that can fulfill dedicated functions in fractions of a second. But if the results of their performance can't be passed on to interested parties, then the whole concept is less than efficient. The problem lies in establishing a communication infrastructure which can handle what is today already becoming an information tidal wave. Without an effective solution, the prospects and effects for tomorrow's users are unimaginable. To avoid this, Philips has been researching ways of overcoming this communication bottleneck. Against a background of global experience in all aspects of communication technology, we have studied ways of applying a solution which can not only meet the needs of today, but also anticipate those of tomorrow, wherever they may be found. The most predictable area is the commercial environment. In offices, communication needs can cover anything from telephones and telex equipment to electronic mail, word processing, and data storage and retrieval. The hospital is another place where so-called office facilities can be applied, particularly in the area of data storage and retrieval, for items such as patient records or digitized X-rays. And in the manufacturing area, the increasing trend towards process automation places equally increasing demands on a communication and information network, because efficiency means profitability. In attempting to come up with a practical solution at Philips, we began by studying those factors which all probable users might have in common. Most communication requirements were confined to a strictly defined area: the office block, the hospital complex, or the factory site, for example. Now, at first glance, this restriction may be surprising. But in fact, no less than 85% of all communication and information transmissions are internal. And of these, some 60% are confined within the same building. Another factor was that the facilities for information interchange within each area had to be characterized by high levels of reliability and versatility, and offer the scope for expansion or alteration as needs vary. The congestion on existing communication channels, plus the growing complexity of cable networks, immediately told us that classical solutions would not work. So, we started looking at the network concept. With the diversity of communication and information requirements likely to be handled by a network, it became clear that the solution should be able to take care of continuous traffic, like speech or video communications, inter-machine dialogue, or requirements of security and surveillance applications. The answer to the needs for carrying dialogue communications is provided by a circuit switching network. The ideal system should also have the capacity to look after the intermittent traffic of word processors, terminals, host computers, and the like. Here, packet switching takes care of the information flow of data processing and electronic archiving equipment. A system capable of integrating and handling both these categories was clearly required. A single, high-capacity cable network with intelligent management and control. Predicted user needs, plus our own expertise and experience, led to the development of a completely new concept: PhiLAN, Philips Integrated Local Area Network. When designing the PhiLAN system, we wanted a carrier that was suited for networks which would be required to cover areas such as those found in an office block, a hospital complex, or a factory. The carrier should also ensure reliable operation in environments where there could be a lot of interference. And it should be able to support a large number of stations. For reasons of performance, ease of installation, and related price, we decided to specify an optical glass fiber cable. The actual network we structured on the basis of ring topology. This is the basis of the PhiLAN philosophy. Let's now see how this design relates to and fulfills user needs. The first step was to choose a transmission method which could provide the multi-channel concept on a single carrier. We looked at FDM, frequency division multiplex, and TDM, time division multiplex. TDM was found to be simpler and therefore less expensive. So we developed a baseband ring network featuring a time division multiplex arrangement. This enabled the total transmission capacity of more than 20 million bits per second to be split up on demand into a large number of independent channels. These could then be used simultaneously for circuit or packet switch traffic. Having established the transmission method to be applied to the ring, let's now study its physical structure. In simple terms, a PhiLAN ring network enables a number of user stations and a ring management station to be interconnected using optical fiber cable. Each station comprises an optical transceiver plus a ring access unit and user-dedicated electronics. The transceiver converts the signals from optical to electrical and vice versa. It also looks after synchronization and system diagnostics. The ring access unit performs message handling, flow control, and error detection for the user equipment. This type of station design enables each one to act as a regenerative repeater for the optical signals. In other words, no matter how great the distance or how many stations lie between the information source and its destination, there will be no loss in transmission quality. To enable both continuous and intermittent traffic to be handled most efficiently, we designed two dedicated ring access units, one for circuit switched and one for packet switched traffic. This means that a versatile and high-capacity information handling system is assured, one whose collision-preventing access mechanism guarantees system stability even at high traffic densities. The ring access unit for circuit switch traffic is a small but powerful switching unit on a single board. It can connect no less than 32 incoming and 32 outgoing user channels, each of 64 kilobits per second, with the channels on the ring, either individually or in combination. Actual signaling is based on a safe message service via a common channel. The packet switching ring access unit is designed to provide a safe message service with packet transfers at up to 4 megabits per second, a high enough speed to transport a page of a digitized document in about 1 second. Now, needless to say, a number of these high-speed transfers can be carried out simultaneously and in parallel to other slower data and continuous traffic information interchange. About 90% of the channels are utilized for the transport of user information. The safe message service and the stable network performance are achieved by using the remaining time slots in a dedicated supervisory manner. This enables circulation of protocol messages and serves as a circulating memory to which all stations have access in a mutually exclusive way. This sophisticated traffic management system is not apparent to the user. What is noticeable, however, is a safe and stable service and stations that act as versatile access points to the system, whether for transmission or receipt of information. And a further important advantage of a TDM system came when we studied long-term projections. TDM is far easier to expand or reconfigure to meet varying traffic requirements. And that's because the organization of actually splitting up capacity into individual channels is looked after by the system software, either automatically or manually under the control of an operator. So no alterations to hardware are needed. In order to ensure the efficient operation and performance of the network and the stations it serves, a ring management system has been developed. In simple terms, it keeps an eye on the TDM structure on the ring and authorizes the allocation of channels to user stations. And the versatility of the ring management system is such that it can easily be upgraded to perform a variety of additional functions. Network status supervision, reconfiguration, error logging, and channel reallocation and system diagnostics. As with most things, however, the concept of a ring network isn't just advantages. There are also a number of disadvantages, and these had to be overcome to ensure the safe, reliable operation of a PhiLAN network. In its basic shape, the ring network breaks down if the optical fiber ruptures, or if a station's repeater fails or becomes disconnected. To a degree, these problems can be overcome by using optical bypass relays. These switch off individual malfunctioning stations, but they can't help, of course, if the cable is damaged. With the PhiLAN system, the problems are overcome by designing it in what we call the meander concept. The ring is subdivided into a series of bypassable fiber optic meanders, or loops. Each one can link around 10 stations. The meanders themselves are connected as a ring in a central module. This incorporates the actual ring management system plus one electronic bypass switch per meander. The switch is designed to enable the information flow to bypass the meander should a signal loss be detected. A microprocessor-controlled version of the switch can also be incorporated in the system to give the operator unit a much more powerful system management facility. When compared with established segmented ring concepts, the cable costs with the PhiLAN meander system are reduced. The PhiLAN system also means that the network optical power level and synchronization are maintained even where a large number of stations are cut off. And because costs of the meander bypasses are spread over something like 10 access points on each meander, powerful control modules can be selected. Right, so far we've been looking at the system layout, how it's designed, its scope, and the fact that it gives exceptionally high levels of system availability at all times. But concepts are one thing. You've also got to have the necessary hardware to enable them to function. Perhaps one of the most noticeable elements in the whole PhiLAN system is the actual wall socket and its associated plug. The plug provides detachable connections and means equipment or services can be introduced into the fiber optic cabling wherever a socket is located. Bypass relays in the socket protect the optical signal integrity throughout the meanders should one station be unplugged or lose power. Now they're too small to actually show you, so here's a mock-up of one. This simple yet remarkably versatile plug and socket arrangement is the point where the user accesses the network. Almost any data generating or data handling equipment can be added to the network as a peripheral, provided its output is digital or can be converted to this format. The choice of passive access points also means that new peripherals can be introduced without any modifications to the network infrastructure. The broadband characteristics of the optical fiber cable, for example, enable transmission of a great number of telephone calls in parallel. These, of course, use PhiLAN's circuit switch traffic capabilities. Packet switching is designed to handle high-speed information interchange using document scanners, word processors, or electronic mail facilities. It can also take care of the interactivity between word processors and a data storage bank. Actual data storage can be handled via the PhiLAN link by sophisticated systems such as Megadoc, a new archiving concept that digitizes pages of text and graphics and stores them on an optical disc using a laser beam. Retrieval of a document takes little more than 1 second. The PhiLAN network can also play an important role in security operations.
Slow-rate television systems, for example, can be monitored at suitable screen refresh rates. Now, for the user, this concept means good levels of security at low cost, because the expense of laying costly video cabling is avoided. Whatever the user requires from equipment linked into the PhiLAN network, however, the information flow must be safe. And with the PhiLAN network, that's what he gets.
No matter how sophisticated a system, no matter how many peripheral devices can be introduced to expand its communication and information interchange capabilities, it cannot be classed as efficient and advanced unless it can offer a safe message service, a service that will guarantee unmutilated delivery to the correct address. Now, this may appear to be an obvious remark, but in practice, most local area networks do not provide this service. PhiLAN does.
With the PhiLAN network, the user gets more than a datagram service, addressed information packets over a shared transmission medium. He gets an assurance that the information will reach its intended recipient. And when it's accepted, that acceptance is confirmed back to the sender. The network itself takes care of flow and error control over all packet transmissions.
In other networks, this is normally left to the user or the actual application to look after. PhiLAN, however, solves this problem internally to ensure the user of optimum communication facilities. Needless to say, the unusually versatile communication advantages which are built into the PhiLAN concept of standard have got to be problem-free and reliable. We've designed the PhiLAN network so that they are, with built-in diagnostics and a fault-finding system. Now, these not only ensure that optimum operational capabilities are maintained, but also enable future system upgrading. The extended diagnostic functions available with the PhiLAN system include operator-controlled network reconfiguration, plus logging and status surveillance.
And to ensure reliability on a round-the-clock basis, the PhiLAN system features automatic defect localizing and isolation routines should a fault occur in a meander. The actual fault-finding techniques can rapidly isolate a problem right down to building, floor, and even room number. This modular approach, and the reliability that it provides, is the heart of the PhiLAN concept. Its meander topology, with central electronic bypasses, means problems can be isolated without disrupting main system traffic.
And the choice of fiber optics and network access via passive optical wall sockets ensures high transmission capacity, plus a long-lasting, flexible infrastructure that protects investments in cables and installations. In addition, today's increasing use and acceptance of fiber optic technology means that PhiLAN components can be easily manufactured.
Automated production techniques ensure high accuracy at low cost in the production of optical connectors and relays. They also mean large quantity production is possible of products that are not only suited to today's performance requirements, but are also easy to operate and install. The result is an assured and continuous flow of information.
Like most effective solutions to complex problems, the basic concept of PhiLAN is quite simple. It has been developed to enable the establishment of high-capacity, integrated local area network communication facilities for now and for the future. Its versatility, capability and flexibility are thanks to the development of a high-capacity TDM ring network which supports a variety of subrings that can be used as channels. Now, by subdividing the complete ring topology into small segments, we have increased the network availability and minimized the effect of component failure. The use of optical fiber cables ensures greater information security, eliminates the effects of interference from external sources, and guarantees electrical safety to people and equipment. The comprehensive communication and information interchange facilities that the PhiLAN concept offers the user are thanks to the systems handling both circuit and packet switch traffic. And of course, built-in reliability in every aspect of a system, with diagnostic facilities to ensure that the user gets the optimum performance 24 hours a day. Traditionally, at Philips, we have always been at the forefront of information technology, with innovations and ideas to help in the easier and more efficient handling of data and communication. With PhiLAN, we complete the picture, providing the vital link to ensure that data communication is available whenever and wherever it's required.